It is given that a bot is floating in water at 0 degrees Celsius such that 97% of its volume of bot is submerged in water. So we can just consider that, let's say, boat or an object is in a liquid. So when an object is in a liquid, this liquid is going to exert some force that is known as nothing but the upthrust, or it is also known as nothing but the buoyant force. So buoyant force is acting on this object by water. The equation for that buoyant force is volume of object inside the liquid. So this is the volume of object inside into density of liquid into acceleration due to gravity, and weight of this object mg is acting in downward direction. So in this question it is given that boat is floating in water at 0 degrees Celsius such that 97% of volume of boat is submerged in water. So we can just consider that 95% is inside. So the volume of object, so you can write the volume of object inside the liquid is nothing but, we can take it as 0.97 because it is given that 97%. So 0.97 times of its total volume or a total volume of object. Now in the next part of question, it is given that the temperature at which boat will just completely sink in water is. So our aim is to find out at what temperature the entire object is going to sink in water. So that will happen when the density of object, we know that if the density of object is less than density of liquid, then this object is going to float on the surface of liquid, and if the density of object is greater than density of liquid, then this object is going to sink in liquid. So if it is just want to submerge, then the condition for that we can take it as density of object becomes equal to density of liquid. So first we can find out from the information, that is the upthrust is going to balance when an object is float in a liquid. Upthrust is going to balance by the weight of this object mg. So upthrust we can take it as volume of object inside the liquid into density of liquid into acceleration due to gravity is going to balance the value of weight of this object mg. So you can write volume of object inside the liquid, or we just identify that volume of object inside the liquid is nothing but 0.97 times of total volume of object into density of liquid into g is equal to, we can take it as the mass of object. Mass of object we can take it as density of object into volume of object into g. So you can write this g and this one get cancelled, volume of object and this volume of object get cancelled. So you can write now the density of object is nothing but 0.97 times of density of liquid. Now as the temperature increases, so in question you can observe that they are given the coefficient of this expansion of real expansion of water. So we are considering that as the temperature increases, water is going to expand according to this coefficient of expansion 3 into 10 raised to minus 4. So we can write the value of gamma of water is given as nothing but 3 into 10 raised to minus 4, and the density of object is going to remains constant. So when the density of water becomes equal to 0.97 times of the actual density of water or density of liquid, so then it is going to just sink in water. So we can use the equation for density. Final density, we know the equation, initial density into 1 minus gamma into delta T. So by using this equation you can write the final density should be equal to 0.97 times of density of water, and because now the density of object is nothing but 0.97 times of density of water, when the density of water becomes equal to density of object, it is going to sink. So you can write into density of liquid into 1 minus gamma into delta T. So we can cancel this gamma of liquid, this is basically water, and this density of water get cancelled. So we can write as gamma into delta T should be equal to 1 minus 0.97. So which we can write that is equal to nothing but 0.03 is a value of gamma into delta T. So the value of delta T, we can write delta T is equal to 0.03 divided by gamma, which we can take it as 0.03 divided by The value of gamma is given in question as 3 into 10 raised to minus 4. So we can write this as 3 into 10 raised to minus 4. So this one get cancelled. So this is going to be 0.01 divided by 10 raised to minus 4, and we know that 0.01 means 10 raised to minus 2 divided by 10 raised to minus 4. So when this 10 raised to minus 4 is coming to numerator, is going to be 10 raised to plus 4. So we can write this as equal to 10 raised to 2, or you can write this as equal to nothing but 100.